part. So we're going to do some special notes here. Special notes. They deserve their own space. And behavior. This is the most important part about today. It's brand new. You haven't done end behavior before. It's brand new. But from starting today, anytime we show you a graph, you're going to be asked end behavior. It's kind of like domain and range. You know how you're always answering domain and range? You're always answering, like you're always going to answer end behavior. Okay, so I want to give it its proper introduction, because if you get it today, it'll be easy the rest of the year every time you see this question. Okay, so let's first write symbols. Math is a lot about symbols, understanding what the symbols mean. So let's write this. Okay, new, it's new. You haven't done this before, so for now just write it down. It's not hard. I promise you it's not hard. It's just new. And every time something's new, it can seem hard, but it's not. So if you're paying attention, you'll be able to catch it. Okay, this is what it looks like. Right? It looks like a bunch of symbols and stuff. Here's what it means in simple English. Okay, so like if I was just explaining it to you in tutorials. As the x, okay, as the x, so I have to abbreviate a lot because I have less space. As the x, this arrow means the real word is approaches. Approaches. So mathematically, that's what that means. Okay. But since I can't fit that big word there, I'm just going to put goes. As the x goes, okay, like approaches. On the x-axis, infinity is at the right or the left? Right. Okay, so as the x goes to the right. To the right. That's what we mean there. Okay. So that x arrow infinity means as the x is going towards the right. What does f of x really mean? Y. Okay. So this means as the x goes to the right, the y, okay, this is the y, that's the y, goes, I don't know, that's the question. Okay? That's the question you're going to answer. So as the x goes to the right, the y goes this way. As the x goes, so this is all the same, but left. As the x goes to the left, what does the y do? Again, you don't know how to answer that yet, but that's what it means. I'm about to show you how to answer it. So this is where does the y go? Okay. Is that okay, guys, so far? Just understanding what it's asking. Okay, I'm gonna switch screens because it's easier for you to see on a different screen. But I want you just to add these little examples like this. And it's just a really small graph, okay? And we're gonna do like 3 or 4 until it becomes really easy. Just add little, when we do them, just do little graphs like that. They don't have to be big, okay? Okay, let's look at the first one. So let me do one, and then I'll ask you guys. So right now on this one, you can add it to your paper, okay? Okay, let's say I had, this is example 1, and it looked like this. Let's say it looked like that, okay? And I would say the questions would be like this. So this is given to you always. So it's always going to say to the right, and it's always going to say to the left. So that's always the same. And then we ask, what is the y doing in this case? And then this say, what is the y doing? So this is provided for you. Okay, that stays the same. Okay, so one way to make it easy for you is just think of a roller coaster again. Okay, and as this roller coaster goes to the right, so it keeps going to the right, more and more and more and more and more to the right. Y is like a height. What height is it trying to go to? Like, the more I go to the right, what height am I going towards more and more and more? Up, right? Infinity. So The more I go to the right, the more up it goes. So infinity. Okay, not infinity because the x, infinity because it's going up, 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 up. As I go towards the left, the more I go to the left, the more I'm going down, 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 right? So we call that negative infinity, down. Ladies and gentlemen, that's what's called end behavior. It's what happens, it's not hard, it's just what happens at the ends. Okay. What are the ends doing? This end is going up, that end is going down. But we write it with symbols. That makes sense? Okay, let's see how much sense that made. So this one had it, and then I'm going to let you answer it, okay? Let's do this one. When you sketch it, don't worry about like, oh, it's touching the 5 or is it touching -4. It doesn't matter because it's only the ends that matter, okay? So just a rough sketch. So this x goes towards infinity, f of x goes toward. I promise you guys, if you get this today, we'll be doing this until May of 2025. Easy question because you'll understand it. Okay, it's the same. So you're just answering this part. Okay, so again, I don't know, if y'all think of a better analogy that would make more sense than a roller coaster, then please share it, just to help you guys out, okay? I was going to use the elevator and height, because I think that makes sense, but an elevator doesn't move like that. But as I go more and more towards the right, where am I going towards on the y? Down, right? So negative infinity, that's down. As I go more towards the left, this is left, so this is left, this is right. As I go more towards the left, where's that arm going? Down. So in this case, they're both negative infinity. Okay, be honest with me because I'm going to adjust to you. How many of you got exactly those two answers? Okay, we're about 60%. Okay. All right, let's try this one. Sample 3. This one's a little more challenging. Same concept, but let me try to throw a curveball at you. I don't know why it's not showing all the numbers. I guess like that. Okay. Okay, try that one. Okay. If you can't sketch it, it's fine. Just the main point is that you understand. So maybe just answer this if it's too hard to sketch. So maybe using the roller coaster analogy, you're describing the height the roller coaster is at. So as you go to the right, what height is it going towards? As you go to the left, what height is it going towards? Okay, so what height, let's do the easy one first. On the left, so as I go more towards left, what height am I going towards? Up, right? So infinite. But here is the curveball. Let's see if you really understood. As you're going towards the right now, go this way. What height, what y is it approaching? It's getting flat, but at -4. Okay. So there's like remember this is the asymptote here. So it's never going to touch. It's going to get closer and closer and closer and closer and closer. Okay. The more you go that way, the more close. How many caught that curveball? You got both of those sensors. Very good, guys. Good job. Almost. Yeah. Okay. I think you guys have it. So let's go back over here. That's end behavior. Okay. So if you're like, oh, that's pretty easy, then good. Good job. Okay. Now here, there's some patterns to this. So it's not that you have to know these patterns, but if you know them, it does make it kind of easy sometimes without you having to graph. So let me show you what these patterns mean. The first one says even power positive coefficient. Example of that, y equals 3x squared. Okay, numbers positive, power, even power. So 2, 4, 6. Let me show you. If you see it one time, then you'll probably remember this. Check this out. Let's put an even power. You know 2. There it is. Look at the arms. I want you to look at the arms. Both of the ends are pointing up, right? What's another even power that's not 2?
4.
Okay, let's put a 4. Both of the arms are pointing up. Now instead of going to 6, let's go, how about we go really big, 44. 44 is even power. Both arms are still going up. 444. 4,004. You know what I'm saying? It doesn't matter if it's even, both of the arms go up. Okay? So if you know that, so it doesn't matter if it's a W or a parabola, the arms go up. So why does that matter? Because if you knew that, then you know that whether you're going right or left, it doesn't matter. Both arms are going up. So up is infinity. Up. Left or right. Okay. What happens to these shapes? So the next scenario says even power, so power 2, 4, 44, 4,044, but negative coefficient. So for example, y equals negative x squared. You guys know this. What does the negative in the front do? Yeah, it flips it, right? It reflects it. So is this, instead of both arms going up, both arms go down. Okay, so I'm going to be lazy and I'm just going to put opposite. Both of them will go down. Both of the arms, instead of going up, will go down. Okay? It's just a handy, it's not like I need to know that, but it's a handy to know, because then if you know that, you can answer those questions really fast. Okay, next one is the odd power positive coefficient. So, for example, okay, the number is positive, the power is odd. So let's take a look visually. Okay, remember the important thing here is to look at the arms. Left arm is going down, right arm is going up, right? Let's put a 5, but even bigger, let's go to 33. Okay. So still, do you agree? Left arm is going down, right arm is going, okay? 333. 3,033. It doesn't matter. Left arm is going down, right arm is going up. Does that make sense? No matter what, even odd number you put on there. So the conclusion there is this, okay, that no matter what odd number you put in there, the right arm, so that's how we say right arm, will go up to infinity, and the left arm will go towards negative infinity. And then you guys said it, the negative in the front for the next one reflects it, flips it, okay? Now here we have two arms, so flip one arm at a time. This arm, instead of going down, now goes up. This arm, instead of going up, now goes down. We just flipped it like that. So again, it's going to be the opposite. Okay, that means the right side is going to go down, and then the left side, when you're going left, that one's going to go up. Pretty easy, right, guys? Not too bad. Okay. Questions right now? Okay. Let me separate